You are on mute, Neeraj.
Oh, sorry. Okay, guys, I'm audible and hope the screen is visible now.
Yes, Neeraj.
Okay, going ahead. Okay, so as discussed yesterday, we are going to talk about the settling mechanism for threads in SQL Server. So we will start to understand the concept of thread, what a thread is, how a query is converted into thread, then how the thread is allocated CPU time by a component of SQL OS, that is scheduler. Then with what phases or what states the thread has to go until its completion, that is called as thread life cycle. Every thread executes under a worker, what worker is, and from there the term comes worker time, we will see. Then we'll see that how the CPU time is allocated by the scheduler using cooperative scheduling algorithm, or that is also known as non-preemptive scheduling algorithm. Before we understand what is non-preemptive or cooperative scheduling algorithm, I will talk about the concept of pre-emptive scheduling algorithm for allocating CPU time, that is called as quantum, which is of 4 milliseconds to any thread for its execution. Also, I will talk about a few concepts that is related to the output of a DMV, that is sysdm OS underscore wait stats. Also, you can find those things in under the task also, dm underscore OS waiting tasks. So those columns are wait time, that is total wait time, maximum wait time, and more interesting is signal wait time, right? So these all things we will start, and many more things will come in picture, such as some weights, SOS scheduler yield, thread pool. I'm not going to touch CX packet right now. That is not in the plan. But if topic will be interrelated, I will talk about that also. CX packet along with cost threshold parallelism. Right. So these are very internals, and whenever you are going to troubleshoot CPU issue, you must have a very good understanding on these all things, along with the DMVs that showed you some statistics, especially DMV wait stats, and then waiting task, and then one is related to your thread pool. The term is issue is related with the thread pool is starvation. I will also talk about that, right? So let's start with the very basic things here, right? So for example, deliberately I have executed this query against a large data set, right? This is not to discuss, just to see here. It's fine. Okay. So you can see that it is a query that is written in T-SQL language, right? When we submit it for the execution, it needs some time for process and then give you the result. That is, it needs some time for the execution, right? We are saying that we have executed that query, but actually we are submitting that query for the execution. Execution is taken care by CPU only, right? So this is a query, right? And one more important thing is how a query is divided is uh, divided into a single thread or multiple thread. It depends upon the query plan, and especially not the query plan, especially the operator that you see in the plan. So what the optimizer has decided how the optimizer decided to execute that query using multiple processors or using single processor, right? Sometimes what happens, even you are executing a simple query and it is operating on a large data set, maximum chance is that query plan that optimizer will generate will be a parallel plan. What does the parallel plan means? Means that plan is not parallel actually, right? The operators that appear in your plan are executed. Every operator represents a task, right? Here, cluster index seek. What does it mean that? Seek means finding, right? It's a read operation to search some values that you have specified here, right? So it is searching for those values using the index seek operator. It's a read operation, but using how many processors? So in this case, I can see that the plan that has been generated is using a single processor for the seek operation, index seek operation, or index find operation, right? How I can confirm that? So right click on the operator, go to the properties, and here you will see something related to parallelism, parallelism. Is that there? Parallel, right? Output is parallel. It is saying false, right? It means that this operation has been completed using a single processor. Parallel is false, right? Now, let us do something different here. Mm, Let us introduce something related to sorting. So order by sales order ID, or do it in different ways. Sales order, okay. Sales order IDs are already sorted, right? No, sales order detail ID is sorted. So sales order ID and make it descending, for example, right? Let us first see its estimated plan, right? Go to query and check for its estimated plan. Display estimated execution plan is here. What it is saying, still it is going with single processor. So that is the estimation, but let us do something more here. Uh, let us go ahead and execute more queries. And this time what I'm going to do is I am just excluding this where condition from the query and then going to execute it. Or let us first see its plan with the estimation. Still, it is going with index scan, still with single processor, but no worries. Let's execute it. It will take more time. While it will be executing, we will discuss some other topics. And at the same time, let's execute this one also. So it's operating on a very large data set. It will take some time, right? But what will happen actually, if the plan which have been generated as a parallel plan, that is one operator or many of the operators are using multiple processors for read operation or write operation. Here we don't have any write operation. But if any read operation or write operation is happening using multiple processors, that is what we call is parallel processing. And that is done only when your max drop value is set other than the value 1. If you set max drop value to 1, always it will, your all queries will be executed using a single processor, right? So there are some standard applications. So for, I know, one is SQL Server databases hosted on SQL Server on VM for SharePoint. That is one example. Another one is for what I saw. I do not remember right now. I mean that some of the applications work better when the max drop value is set to 1 because their application code or SQL code are written in such a manner which gives the best performance against the max drop value 1, right? But otherwise, it is suggested to go with the parallel processing, right? So let us come back to the thread now. So I submitted this query for the execution, right? Uh, its plan has been generated. Now the plan is serial or parallel, maybe serial, maybe parallel. It depends on the optimizer that what it will choose as a serial plan or parallel plan. So if it is a serial plan, means that this query will be a single threaded query which will be submitted to the scheduler for its execution as a single thread. If it is a parallel plan, definitely that will be multi-threaded query, and we can't decide that with how many threads it will be with how many threads it will be divided into how many threads, and then the number of threads that query will be divided accordingly. It will be executed with the relevant processors. So if a query is divided into 4 threads, then parallelly it will be processed by 4 processors. If it is divided into 8 threads, parallelly it will be processed by 8 processors, right? But let us come back now to understand actually how this happens. But here it has executed. So again, it is serial. This one is serial. This is again executing. Let it come. We'll see. Okay, so it's saying. Okay, so now let us come back to the basic. We submitted the query for the execution. A plan was generated based on the serial or parallel plan. The query was divided into multiple user query threads. Always remember, there are 2 types of threads. Whatever queries you are executing against the databases, those are treated as user query threads. But at the same time, SQL Server in the background runs multiple system threads or system level threads, right? For processes such as lazy writer, uh, deadlock manager, right? It executes background processes as threads. So those are system threads. And every thread is executed in SQL Server against a session that you have to remember. So when a query is divided into multiple threads, you will see that under a single session, multiple threads are executing, right? I will show you after some time if any parallel query will be there. I will show you. Is it completed? An error occurred executing batch error. There is no enough space on the disk. Oh, that's the problem. Why? Which disk I don't have a space? Let me check that. Stop this PC. No space is there on the C drive. So basically, it was using page file. It was using paging for virtual memory and it didn't get enough space. What I can delete from here. We have something here now. I have to install something then, right? Let me go to control panel. Let me install it fastly. You will see Oracle. I don't know how much space it will release. Let us see what is the size of this folder. It's only 1.23 MB. What is the size of this one? 502 MB. All lot in MBs. It is asking, okay. Do we have anything in data? No. Still, we don't have much memory. Visual Studio. Let me uninstall it. This takes a lot of space. But it will take a lot of time. Okay, let it go. We will back then. Okay, so let us go with the discussion here. So when we submitted the query for the execution, plan is generated. The plan may be serial or parallel. If it is a serial plan, that query will be represented as a single thread to the scheduler. So what a scheduler is, scheduler is a component of SQL OS. SQL OS is a virtual operating system and it was introduced in SQL Server 2005. And the main objective was to have SQL Server its own scheduler to allocate CPU time to the to the SQL Server query threads for the execution. Why? I will talk in a while. So that is your SQL OS. Then SQL OS has a component called scheduler. Along with scheduler, it has also a component that is known as worker, right? Let me come back here to the document and let me show you something interesting. You see here, we are trying to find here top 5 or 10 queries based on the total worker time, right? So from where this concept is coming, right? This concept is coming from the worker. How much time a query has spent under a worker for its complete execution, that is known as total worker time, right? So many of the people execute this query to get the top CPU consuming queries by the elapsed time, right? And that is captured under total worker time, right? So what this worker is, let us talk about that. What happened to this? Okay, it is going on. So when we execute the query, right, uh, basically it is divided into thread, and now sorry, not divided into thread, a plan is generated. That if that plan is serial, that query will be represented to the scheduler as a single thread, right? If the plan is parallel, that query will be represented as multi-threaded query. It may be two-threaded query, four-threaded query, six-threaded, eight-threaded, 12-threaded. It depends on uh, how many processes you have on the system, right? And what is the max top value you have set for the server level. So say, for example, if you have 16 processors, but the max top value you have set is 4, right? Then in that case, even though that query is a good candidate to be executed by 8 processors, but still it will be divided only into 4 threads and will be allocated by the scheduler to the 4 different processes for the execution, right? There is a relation between scheduler, processor, and worker. Let us try to understand that. So to find out how many processors you have on your system, right? How many processors you have on the system, right? What query you should use? Select a start from this dot dm, where it is gone. It's stuck. Since it is stuck. Okay, let's rewrite it. Select star from sys dot dm underscore OS underscore. What is that? Sysinfo or server info? Sysinfo, right? sys.dmos sysinfo. So how many processors we have here? We can see CPU count is 4, right? That's fine. Is it giving me information regarding scheduler? Yes, it is giving me information regarding scheduler also. For 4 processors, we have 4 schedulers, right? So your scheduler count will be always equivalent to the number of processors you have allocated to SQL Server. Let us do one experiment here. Let us assign only 3 processes to SQL Server this time. Go to the processors and uncheck these 2. Go here, expand the NUMA node, and 1, 2, 3. I'm assigning only 3 processors. And going back now, let's execute it. Here CPU count is 4 on the server. Let us go to see the scheduler here, but the scheduler count has been reduced now, right, to 3, you see here, right? So these are user schedulers, which are 3 only. So how many logical processors you have allocated to the SQL Server? Accordingly, the schedulers will be created, right, by SQL Server upon its starting, upon its start. Whenever SQL Server starts, it reads the CPU affinity value, right? That how CPU has been affinitized, and accordingly it creates the scheduler. So now we have only 3 schedulers. Let us back it to 4 now. It's fine. Let us go ahead. Okay. Let us check it again. Let us execute it. So CPU count is 4 on VM level, and for that now 4 settlers you have, right? For 4 settlers, how many workers you have? You see here, max worker count. It is 512, right? There are 2 things that you have to understand from the worker concept. 2, 3 things, right? Before a query thread starts to execute under the CPU, that query thread has to be assigned with a worker thread, or simply called worker, by the scheduler, right? So for 4 schedulers, here you have 512 workers. If you have 8 schedulers, I think you should have 576 workers on the system. If you have 16, I hope you should have 716 or something, right? You can Google that. What I mean to say, more the number of processors you assign to SQL Server, or more the number of processors you have, more the number of schedulers you will have, right? And more the number of schedulers you will have, more the workers you have. Why I am talking about this? Sometimes what happens, with the lesser number of processors, you have lesser number of workers, and the workload is high in terms of queries. So say, for example, there are 3,000 connections established against SQL Server by 3,000 users. And they all are submitting their queries per second. Every second they are executing their queries. Their queries are taking some time. Some queries are executing in a second, some are in 10 seconds, some are in 60 seconds, some are in 300 seconds, right? So every query has been converted into thread, and every thread needs a worker for its complete execution until and unless a scheduler will not assign a worker to a thread, that query will not start execution. Even it will not enter into the runnable queue of the scheduler. I'm going to talk in a while. Runnable queue. So what happens when the workload is very high against the SKU that you have, or the hardware capacity that you have, especially in terms of processors, right? You will have a situation that is known as thread pool starvation, or sometimes it is also known as thread pool churn, right? So this is a question that is asked in Microsoft: what is thread pool starvation, right? These things you have to understand in order to measure the workload, right? So how you can say to the business that the work pressure or the workload that has been put on the system is more to handle than the resource, hardware resource, especially the processors that we have now, right? Where this knowledge comes in picture. You have to show them the thread pool starvation that is happening. If time will allow, I will show you today. Let us first cover all the basics today. Basics, but not basic. These are very advanced things, right? For me, it may be basic, but these are very advanced things. So is it clear that the number of processors you have in the system, equivalent number of schedulers you will have, and for each scheduler, you have some workers. For example, you have 4 schedulers, then just divide it into each of the scheduler, it should come 128, right? So 128 for each of the scheduler, 128 workers you have for each of the scheduler, right? There is a relation between scheduler and worker, right? That relation is known as master-slave relation, right? That relation is known as master-slave relation. Scheduler is the master and workers are slaves. So all workers all obey the order of the scheduler. Slaves have to obey order of their master, right? So schedulers are masters and workers are their slaves. They obey their master. What does it mean that? Let us come back to this topic now. That is gone. So we're on the top then. What was that? Yeah, right. So far so good. Any question? Do you have any question? Yes or no?
Neeraj, besides the scheduler, we have scheduler total count, which is 14. So right now
Mhm.
we have 4 schedulers
Okay,
assigned.
good question.
Yeah.
Yeah, so let me come back again to that topic. Am I audible?
Yes.
Okay. So that the scheduler that it is showing is user schedulers, right? Now there are system schedulers also. Those system schedulers are also bounded with the CPUs. I forgot to talk about that. Good question. Let us discuss about that. Select a star from sys dot dm underscore, sorry, not dot underscore os underscore schedulers. Is it coming? Schedulers, right? So you will see there are many schedulers here, right? You see on the top, you have four processors here, CPU ID 0, 1, 2, and 3 for four processors, right? First processor is CPU 0, then 1, 2, and 3. And for that, you have four settlers with settler ID 0, 1, 2, and 3. So these are your user settlers, which are responsible for allocating CPU time to the user query threads. But apart from that, there are system settlers, which are basically assigned with a very high settler ID values you see here, right? So that's why the count was showing 13 or something like that, right? 14, correct? Apart from that, all user settlers are always visible and online. System settlers are always hidden and online. You see here. These are these are managing background processes. So they are hidden and online. And one is there that is with one settler is there that is with higher number. And this is the scheduler ID for this. This is always used for DSC connection, DAC connection, dedicated administration connection. This scheduler is always reserved for dedicated administration connection. That's why when your system almost is in hung state, right, you can have the DAC connection even in case your system is in the hung state, right? And when your SQL server is in hung state, right, you can connect through dedicated administration connection, right?
Okay, Neeraj. So out of the 512 worker threads, we
Mhm.
got the worker count as 512, right? So out
Mhm.
of them, can we differentiate which worker threads were assigned by system schedulers and which worker threads were assigned by user schedulers? Out of the 512, can we differentiate them? Any query we can get it?
So, of course, we can find that, but here, what you see is system level schedulers, you have this much, right? So wherever you see these IDs are coming for the threads, right? You can identify that these are related to the system settlers, right? And wherever you see these settlers ID 120 123, you can say that these are related to the user query threads, right? So for that, settler queue, there is a query. Let me find that out. Basically, with the system schedulers, you will always have lesser number of sessions. So you will see lesser number of workers in that case. But let us try to find that out. If I
Yeah,
can
but
find.
sometimes that will help us troubleshoot or identify if there are any CPU issues, CPU bottleneck issues.
Mhm.
If the system schedulers is causing much pressure on the on the SQL server
Mhm.
when compared to the worker schedulers, okay, then
Right.
we can, yeah, then we can decide, like, or maybe because
Mhm.
of the system schedulers, system processes, the CPU spike is happening, right?
Right, right,
So,
right.
so maybe that also we can use that to resolve CPU related issues.
Mhm.
Yeah.
Right. So let me try to find in this way. Does the scheduler stores any scheduler queue that is showing here? Under this, do we have anything? Preemptive switch count, context count. Here it is, right? Current worker count, right? You see here. So this worker
Yes,
count
correct. Mm.
shows 21, 24, 28. So these are all are related to the user query threads. And below this, you have the worker counts for the system threads, right?
But those do not sum up to 512, right? That's what. It's
So
huge in number.
no,
Yeah.
so that is not is in use, right? All are free.
Yeah, free. That's what. Yeah, that's
Yeah. So just to
understood. Yeah,
minus,
self-explanatory. Yeah,
yeah,
correct.
yeah, total these all and then deduct, I mean that subtract that from 512, you'll have.
Others are waiting to be assigned. Yeah,
Yes, so that is a
yeah.
good point again. You must have free workers, right?
Yes, yes, yeah.
If you don't have free workers, then how the new request in terms of queries are coming to SQL Server, how SQL Server will, assign the workers. If so, that is the case when you don't have free workers, right? Then the query thread has to wait for the assignment of the worker. Now we have a very good background. Let us go ahead and discuss about the execution of the thread, how it happens, and that will form the thread life cycle. Very
Also,
good.
I need the comparison between last execution time, total elapsed time, and total worker time. What is the difference between them? Total
Yeah,
elapsed time and total
I'm
worker time.
coming. I'm coming to that, right?
Oh,
That is in the agenda, right?
okay.
So let us go there. So now that is a good background that we have prepared to understand this now, right? So here, what happens that when a query is converted into a thread or multiple thread, it doesn't matter. Every thread reads to the scheduler. Now the scheduler has its own queue that is known as waiter queue or waiter list, right? Here, the query thread is waiting for the assignment of a worker. Now, is it clear that if worker is not available, right? The worker is not available, then what will happen? That query thread will wait in the waiter queue or waiter list of the scheduler itself, right? So why it is waiting? Because the worker is not available, right? So when the worker is not available, and if the query thread is waiting for a long time when I say that refers even to 300 milliseconds, 200 to 300 milliseconds in a busy system is a, long waiting time, right? So not in second even, right? So if the thread is waiting for a longer time, that is 200, 300 milliseconds or even a second, right? So that definitely gives birth to your thread pool churn because you don't have workers for the for the allocation by the scheduler to the threads, and that ultimately result into a situation that is known as thread pool starvation or thread pool churn, right? So this is clear. That is the issue, right? What is the resolution for that? The resolution is you analyze the workload, right? And see that if those workloads are coming from jobs, can you schedule those jobs on different schedules? If those are coming from jobs, that is fine. But if those all are coming from users, right? And those all users are in the same time zone, you can't do anything, right? So for that, the solution is to increase the number of processes on the system, right? You can do only two things, right? Either increase the number of processes on the system you can recommend with your analysis, or you can say that limit the workload or lower down the workload, right? If that is not possible, then definitely you have to increase the number of processes in that case. So now, up to this point, you all are clear? Yes or no?
Yes.
Okay. So once a worker is assigned to a thread by the scheduler, then it moves into runnable state And this is another queue of the scheduler, right? Now, in the reliable queue, the thread is waiting for the assignment of CPU time. The CPU time is assigned to a thread in terms of quantum. A quantum is of 4 milliseconds only. When a quantum is assigned, that is 4 milliseconds time of CPU is assigned to that thread, then it enters into running state. The thread will start running, query thread will start running if the resources which it has to operate either for read or write operation is available. If it is select query, definitely it is a read operation. If it is insert, update, or delete query, definitely it is a write operation, right? So the table and the number of rows which it is trying to, say, for example, read is available, which is not right now exclusively locked by other any other transaction or any other session, I would say, right, or any other trade, then it will start running, right? So it will run for its 4 milliseconds of time, and then again it will back to the runnable queue, right? Those query threads which have been allocated 4 milliseconds of time and the resource on which it has to operate, that resource may be a single row, a range of rows, right, a page, more than a page, even all pages, right, a schema or the database itself, whatsoever it is, resource, right? Database resource may start from the single row and it can go up to database level. So if the resource is available, right, what will happen? That query thread will execute for 4 milliseconds of time, and again it will back to the runnable queue where it will wait for its next allocation of 4 milliseconds. Again it will be allocated, again it will run, again it will back until that query thread execution will not complete. But what happens when the resource is not available, right? 4 milliseconds time have been allocated to the query thread. The query thread entered into the running state, but now the resource on which it has to operate is not available. We will see through example now. If that is not available, then what will happen? In that case, what will happen? The query thread will put itself into suspended state and it will relinquish or free its 4 milliseconds of time that was allocated to it for the utilization by other threads. And this algorithm is known as cooperative scheduling algorithm. Especially you have to understand here, when a query thread is allocated 4 milliseconds of time, it has started executing, but the resource on which it has to operate, either for read or write operation, that may be a single row, that resource may be a single row, a range of rows, a page, many pages, a table, right? Anything it could be. If that is not available, then the thread voluntarily put itself into the suspended state and it relinquishes or frees its FREES, freeze its 4 milliseconds of time to be utilized by other threads which are in the runnable queue waiting for the allocation of 4 milliseconds time, right? This algorithm is known as cooperative scheduling algorithm or non-preemptive scheduling algorithm. Opposite is preemptive scheduling algorithm. Preemptive scheduling algorithm is what? When a thread is allocated a 4 milliseconds of time and the resource on which it has to operate is even not available, not free, it will not relinquish its 4 milliseconds of time, or it will not free its 4 milliseconds of time to be utilized by other threads. Rather, it will sit idle for the 4 milliseconds, which is vestige of the CPU time. This is not the single thread for which the case is that the resource is not free. There may be hundreds or thousands of threads for which resources are not available. And if they all are simply sitting for 4 milliseconds, ideally, suddenly it is the vestige of CPU time. And this is what is known as pre-emptive scheduling algorithm. And that was used in SQL Server 2000, right? With the help of Windows operating system. And Windows operating system, regardless client or server version, is still using pre-emptive scheduling algorithm. Windows operating system does not use cooperative scheduling algorithm. So to have SQL Server, its own scheduling algorithm or scheduling mechanism in terms of cooperative scheduling mechanism, SQL OS was introduced in SQL Server 2005, especially to have its own scheduler with cooperative scheduling algorithm. Is it clear? Any question here? Okay then. So what is the time? It's 7:02, right? I will be back in 2 to 3 minutes. Let us wait for them. So I'm not pausing this recording today. Yesterday, half of the class recording was not done because I paused, but I didn't resume that. So I will be back in 2 3 minutes. Okay, guys, I'm back now. So let's see this states here with an example. I hope you all are back.
Yes.
Talking about these tables. You have that. Unit price 2000, set this. Let's change this context to DBO. DBO. I have a big table. I want to do some experiment there. And it should be my sales order detail table. Let it be there. That's fine. Same thing will be here. Control C, Control V, 202 for this. This we are executing from session ID 66. Let us copy it into a different session. Say, for example, this one, 60, 54, 54. Let's comment this out. That's fine. So let us come back here. What I'm trying to do here, I am trying to update the unit price column of sales order, my sales order detail table. Here it is sales order detail table. For all the rows, well, sales order ID is 43659 from one of the session. From the another session, same thing I want to do on the same resource, but with a different unit price value, right? You know that modification in a table is only possible when the exclusive lock is taken on the database resource. In this case, if it qualifies for less than 100 rows, there will be row level locks. If it qualifies for more than 1,000 rows, it will be page level locks. We are not sure what kind of lock it will take. For that, we have another analysis that we can do using translocks, DMV translocks. We are not going to do that. What my objective is here, what is my database resource? Say, for example, in this case, there are 50 rows which are qualifying for sales order ID 43659, right? So these 50 rows will be exclusively locked, or just talk about 500 rows, right? For the operation, for the modification of 500 rows with unit price 2000, say for example, it will take 1 second, just assume, right? Same time, if another user execute the same query, which is trying to modify unit price with 2022, so those 500 rows are already exclusively locked. This query thread, rather it is transaction here. So this query thread will have to wait, right, for one millisecond. And in that time, it will show in the suspended state. Let's see it here. If that will not reproduce, I will forcibly uh, wait it for some time. But let us see first. So which session should I execute first? 2020, this one. Let's try to find out how many rows are there with this condition first in this table. So we will have some idea how much time it is going to take. there or not. What's wrong? Oh, set should not be there, right? Mhm. Invalid object name. It does not exist. Surprising for me. Is it not there? Database. This one, tables, DBO. My sales order detail is there. Why it is not recognizing? Maybe the table name is incorrect. No, it
Order
is
spelling
correct.
is wrong. Yeah.
Sales order ID is also wrong, right? Sales or order ID. Order ID. It's 4,008 rows it is qualifying for. Or can we make it bigger? Yes. Let us do something here. Sales order ID, this. Let us introduce between this value and sales order ID equals to, let us make it, say, for example, 4, 6. Let us copy it, Control C, this one, where Control X, sales order ID, for the where sales order ID, between, right? Between should come here, and simply this value. That's fine. Control C. Let us remove this completely. Now see how many rows it is qualifying for. Yes, good number of rows. That is what I wanted. Okay, that's fine. Let's comment it out and copy this one to this query window. What happened? Hey guys, just a minute, someone is calling.
You're on mute, Neeraj.
Give me a minute. What I was talking? Mm, Do we have the same condition? No. Let's replace this code here. Is it copied? This is copied. So we have to check for the state. Select start from start. We can go with sys processes, the very fundamental. How many sessions we have? 29 from 52. But these are again related with, many of them are related with system level components. Not a problem. We have session ID 66 and 80. Sorry, 66 and 54. Let's confirm it. My sense of a detail is here. And my sense of a detail is here with this between. Okay, that's fine. Let's execute it. It will do updation. Hey guys, allow me for 1 minute. I'm getting disturbed on phone. Okay, let's execute it. Then let's execute it also. And come back to this. Check for the thread status now. So we should have 54 and 66. But should have been captured 54. 54 was in runnable state. Here you see, and 56 should be in 56, 66, right? 66 should be in suspended state. 66, where it is gone? 66, 66, 66, suspended state, right? Why it was in suspended state? Because the matching rows, that is how much it is, 40 lakhs, 8,545, 49 rows were exclusively locked by this transaction. It means that this transaction is exclusively locked this these all rows, right? So the relevant query thread was waiting for this resource to be free. Although this query thread, when this transaction was submitted for the execution, ultimately it was a query thread. So this query thread was waiting for that resource to be free, right? So now one interesting thing we can find here, let us do some more experiment now. Let's change this value to 230 and come back. Let's change this value to 240. Okay. And give me a minute again. Okay, I'm done. Whatever I was doing on Paytm. That's fine. So what is my planning now is to capture the plan as well here. Or let us do two things. Let us capture the IO statistics and time statistics. So set, what is that command? Time on, set CPU time on, what is that? Set
Statistics.
statistics time on and set statistics. It's be called IO on, right? That's fine. Control C. Let's put it here also. Now, that is fine. Let's execute it. Execute and execute. We didn't capture the plan, right? Okay, no worries. Okay. So now come to here. That is for our US statistics. Basically, the time is here. Let us see the first query now. And my focus is here, right? So two important things have been captured under the CPU statistics, CPU time statistics. One is CPU time and another is elapsed time, right? CPU time is the code time which was taken by the processor to execute the query, right? And elapsed time is the total time which the query took to execute, including wait on the resource, then wait on network, right? Wait on IO operations, everything is included here, right? So if you see slight difference between the CPU time and elapsed time, you don't have to worry about. Here we are fine. There is a difference almost 600 to 700 milliseconds, right? But if it is 2 times, 3 times, 4 times, 5 times, 10 times greater, elapsed time is 3 times or even 2 times, 2 times, 4 times, 3 times, 5 times, 6 times greater than your CPU time, definitely your transaction or your query thread is waiting for the resource, right, to be free, and that's why you see the status of the session that usually represents your thread status, right? I am talking about this, but now it will not represent. So here we are fine. What I want to say, for the first query, we are fine. But if you come here, you will see a lot of difference between the CPU time and the elapsed time. See, almost 2 times, not 2 times, but almost, right? So there's a difference of almost 5 seconds, right? It means that this transaction or this query thread waited for the resource for more than 5 seconds, right? So that is the important catch, right? What's the difference between CPU time and elapsed time? Many of the people are very confused, and this gives you a very good idea, right? Where the query is actually taking time for the execution, or actually it is waiting for something, right? Waiting for some resource. So when it is waiting for some resource in the session state, it will show the status as suspended, right? So to prove that, let us do this experiment once again. Come back here and change this value, say for example to 240, or 240 was already there, I guess, 250, and make it 260, right? So we will execute it quickly. Third query is ready here to capture. So this one, what happened? Again, the system is in hunger state.
You can use a tree free size freely downloadable tool to determine which folder is having more space, is occupying more space. Neeraj.
Folder?
Yeah, tree free size. In our organization, we do that. In the servers itself, we will
No,
deploy.
that is not a problem.
Yeah, because very frequently, every now and then, it is happening, right?
No,
So that is
it is not happening due to the space. This
the
usually
memory.
happens. No, this usually happens on Saturday and Sunday on Microsoft.
Okay.
This VM is in Azure, right?
Oh, okay.
No worries, how much seconds is
What
take.
one doubt I have, Neeraj, see,
Mhm.
we are updating the same number of rows, right? Why
Mm.
locks did not happen? Why one session did not wait for the lock, waiting to be released? Two sessions, in two sessions, both queries got executed successfully. I thought that one query will be
No, no,
waiting.
no, no. Second is waiting, right? Second is waiting. That's why that is what I was explaining. It was
Ah,
waiting. That's why there is a difference of 5 seconds. If you
oh,
come
waiting
here,
means it should show executing, right? Where did we see the executing?
no, it is showing executing, but if you check blocking, you will see that 66 is being blocked by
Blocked by, that
54.
is what I want to see in the sys processors.
So no, no. So I am showing you in different way, right? That is
Okay.
known to everyone. Blocking is
Mm,
known to everyone. How to check that, right?
mm,
This
mm,
is more deeper, right? My focus
mm.
is on CPU time versus elapsed time, right?
Correct, but I thought that session itself will be in executing state, but I don't see that it is in
No, no,
executing.
session is always in executing state. When it is also suspended, it will show you in say, no, no. Here it will show in executing state, but in a SPID status, it will show in suspended state. Let us check that.
Mm.
Oh, this is ready. This is ready. Let's execute it, and then let's execute it. Let's check the status of the thread now or the session. So one is 54. 54, 54 is in runnable state. The time at which we executed was in runnable state, not in running state. And 66 should be in suspended state. 66, you see here, it was waiting on this table, right? Uh, it is in suspended state. That's fine.
So if the first query is in running state, how would we interpret it? It is
Sorry?
in run. If the first query is in running state instead of runnable, then how
Mm.
would we interpret it? That means we have to wait for the status
No, 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 no.
to
So
be changed from running to runnable. You
no, no,
said
no.
that every four
See,
milliseconds. Yeah.
it is changing so frequently that it is hard to capture the running state, right? It is switching from
Correct.
running to runnable,
Correct.
running
That's
to
what you told,
runnable.
right? Yeah. Yes.
Yeah,
Yes.
it is switching so hard,
Yeah.
so fast, right?
Yeah.
So maybe the chance that you will see that it is in running state, right? So it
Correct.
is switching from running to runnable, running to runnable. If it is in runnable state for long time, right, that is a problem,
Okay.
right? It means that something is compelling the thread not to enter into uh, you know running state. It means that it is not getting the 4 milliseconds of time,
Correct.
right?
Yes.
So this is about the status. Again, let's do one more experiment here, and this time we will capture the execution plan also. So let's change it to 70. Let's back it to 20 and capture the actual plan. Display estimated. No, include actual plan. Come here and then include actual execution plan. Right. We are fine to go. Let's execute it. And then let's execute it to execute it. It 54 is in runnable state. 66 should be in suspended state. That's fine. Now coming back to its plan, execution plan. Let's come to the last operator and right now in its properties. Go to the properties and here do we have the CPU time captured? Compile time, degree of parallelism, memory grounds, parameter, statement, what is stats. So, no worries, CPU time we are getting from there also. I thought that it is also captured here. Estimated operated cost, zero parameter. Where I can capture that one. Don't think it will come from here. Leave it. Leave it. Anyway, we are capturing the CPU and elapsed time here. Right. So that is the first one. There is a difference, slight difference, where there was no waiting time. Right. 703 and 798. 978. 200 something, 275 milliseconds difference. But here you will see a lot of difference. That is 9017 and it is 18, right? Almost doubled waiting time. So that was the objective, to talk about CPU time and elapsed time. Now coming to the worker time, right? So let us do some investigation, and I hope that elapsed time should be very close to the worker time, because worker time is what, let us back to our discussion again. Worker time is this one. This one. The worker has been assigned to the query thread when it was in the waiter queue of the scheduler. And now it has assigned a 4 milliseconds of time. It's started running, right? It is running, and going back to the runnable, coming, and then when it completes its execution, then that time is known as your elapsed time. Or even when it went into suspended state, and it waited for the resource to be free, and again it back to the runnable queue, then again it was assigned 4 milliseconds of time, again it back to the runnable queue. So anyway, that is captured under the worker time. So once the thread gets its execution, the worker will be snatched from that thread, because that successfully got executed. And now that thread is available for, now that worker is available for new threads to be assigned by the scheduler. So your elapsed time should be very close to the worker time, right? Let's do some analysis on that. Any query is fine. Total worker time, the average CPU time. No, let's go with this one. So how many executions? It's showing one execution. Oh, query was different, right? Total worker time in MS. Last time. Last query. Let's check for the last query. This is my last query, right? Total worker time was here 7802. One execution 7802. So it should be close to the elapsed time. So 7802, where this value is matching. Message. This is not here. Uh, This was for the waiting one. And This was for this query. This is even bigger. 54. 66. What is this query? 2022, right? 66. And if we come here, 2040. 2020 has not been captured under 10. So I remember that was close to this, right? Elapsed time 7802, something like that. It was there. Let's remove. Let's go with top 15. So it should give me this one, 2020, the last one. Execute. This is what 2000 2020, where that is. Should be 2 times 2020. Execution count is showing only one. 991 total working time average. You will see it will be very close, right? Worker time and elapsed time are very close. That is what I am seeing for 2040. I remember that was close to this one. The elapsed time was close to this one.
Both are worker time only, right? Neeraj, here, total worker time and average worker time. Total elapsed time is on the sixth or seventh field column.
Where is that?
Here, 12698. Almost
it is
2 times. Yeah.
Why it is 2 times? Execution is only one. Average elapsed times is same.
Yeah, but total worker time and total elapsed time are entirely different.
This has more value, right?
For all the rows, it is like that only. It is entirely different.
So then total worker time. Did we capture the CPU time? Let us focus on this one. The last one was 2020, right? 2020. And total worker time is here 9101. 2020. So it is close to the CPU time. But conceptually, that is not correct. Total worker time is the time under which a query took its time for the total execution, right? So that should be close to the elapsed time. And for 2020, elapsed time is here 18528. Let's check that. For 20, yes, you see here. That is correct. For 2020, I am checking, right?
Total worker time is close to CPU time.
Yes. The total elapsed time, right? You see here. No, I'm not talking about the total worker time right now, right? I'm talking about the elapsed time.
Yeah, that
right?
matches. Yeah, that matches.
So that matches here. But total worker time, why it is doubled? By definition, we say that in theory, a worker is assigned to a thread and that thread will wrap it until its complete execution, right? So it should be very close. Total worker time should be very close to the elapsed time.
Elapsed time, yes. Theoretically,
So
it should be like that.
maybe total worker time in MS. Let us check that from where it is coming. As a statement in total worker time divided by 1,000. Total worker time in MS. Total worker time execution count. Total logical reads, average logical reads, execution count. Just a minute. हाँ पांडे जी. Okay, I'm back. So we were talking about total worker time versus total elapsed time. Elapsed time is clear, that has been captured as per expectation, but total worker time here, I'm not agreed with this. Why this is coming in this fashion?
Yeah, just now saw
Something
in
it is something more than the CPU time, right? Something more than CPU time. CPU time was showing 7,000 something, right? Yeah. What you were saying?
in copilot.microsoft.com. Just now I saw total worker time is nothing but they are equal. They are. It is saying that total worker time is nothing but the CPU time. But theoretically, it should be elapsed time, right? Even in Copilot also, it is showing the same thing. They are making it as alias worker time alias with CPU time. It's in the queries they have written like that.
With the statistics, it shows that, but then
Yeah.
then the definition or the working principle, right?
Correct. The theory is not
Is
matching.
the theory is
Yeah.
not matching, then something is wrong with the query that Microsoft had designed, right? The column
Yes.
under which DMV under which this column is there, something I'm not agreed with that,
Correct.
right?
And one more thing, Niraj, elapsed time should be, is that elapsed time should always be greater than CPU time?
Uh, it will be most of the times slightly greater than, but
Exactly.
if
Slightly greater. Correct.
yes, slightly
That
greater
is
than.
reasonable. That is reasonable. Yeah.
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 Okay, so who are there? Who is from Lenovo? Varun is there, Abhijit is there. One more guy joined, he dropped in between. Okay.
Sir, I am Dheeraj, joined from Lenovo.
Okay, that's fine, Dheeraj. Okay, it's fine. So now we will start the batch from coming Saturday, right? And I will not going to send further invites, right? So I will broadcast the batch starting date. Whosoever is interested can join this batch by enrolling into it. The course fee is 16K, right? So I will share this recording with all of you, but how? That is the question. Either you ping me on WhatsApp or you give your mail ID I can give you this recording, right? You can circulate it to your friends also, right? So 875056 0006 is the number on which I'm reachable on WhatsApp. You can ping me on this. One way is that I can send you the recording link there, or I request you to ping your email ID. I can send the recording links over your email. Either way, I'm fine. Okay.
Neeraj, can you please share me the scheduled timings of these sessions? Because
Timing is this. Timing is 6 p.m. to 9 p.m.
every day or weekends only?
Every Saturday and Sunday, not every
Every
day.
Saturday and Sunday. Okay, fine.
Yeah,
Fine.
if you don't have the syllabus, you get it
I have the
here.
syllabus. I had the syllabus. You shared me
Okay,
initially, right? At the
okay,
start of the session, you have shared me that. Yeah, I have
okay.
it.
If anybody wants, I can save the syllabus again. This is so it's a big course, right? Very large. I mean that very broad. Range is very broad. A lot of topics are there. Okay, then, guys. We'll see you in next week then. Thank you for time.
Thank you.